This assignment is about 3 topics: indirect measurement, rescaling, scaling up or scaling down, and transforming measures. Later, we'll be applying these topics to data. But, in this assignment, we'll again be applying them to shapes and distances. And again, the goal is to develop ways to visualize things that we'll be doing later. One way to measure the height of a tall tree is to pick a point P some distance away from the tree. Then, count footsteps from P to a point A at the bottom of the tree. Next, sight from P to points N and B at the bottom and top of the tree. And, one stride length from P, mark the point A' and B' as shown in the diagram here. The red triangle PAB should be similar to the triangle PA'B'. So, if you imagine filling the big triangle with copies of the small red triangle, then you can see why the formulas at the bottom of the screen are true. Here is another way to think about the kind of transformations that we have been investigating. Imagine 2 sets of parallel lines, like the red lines and the blue lines shown here. If both sets of lines are parallel, then distances are preserved. But, if one set of lines converge to a point, then only ratios of distances are preserved. And, this is true regardless whether it is the red lines or the blue lines that are converging. Next, let's see how parallel and converging lines look when we are thinking of transformations of data instead of transformations of trees or geometric shapes. This diagram shows 4 identical sets of data. As you can see, if we draw lines to connect matching data points, then the lines are parallel. But now, notice what happens when we subtract the value of the minimum score from each of the other scores. The red data set shows the result. Next, let's stretch the green and blue data across a larger interval. Notice that the dotted lines between the red data and the green data now converge at the blue point. And finally, let's move the data so the minimum value is at any point that we wish. And again, notice that the dotted line between the blue data and the black data or the red data will converge at a single point, which, in the case of the black data, is off the left side of the screen. The table and graph in this Fathom worksheet show test scores for 24 students. The start column shows the original scores that were given to the students, and, in the Fathom worksheet called Rescaling Test Scores, 1.5.2d, your task is to use the sliders at the bottom of this worksheet to transform the end scores so that 50 is the lowest score and 100 is the highest score. After you have succeeded in transforming this first set of starting scores, go under the Fathom's Edit menu and copy your results as a picture. Then, go to Fathom's Collection menu and select Randomize to see a new set of starting test score data. Again, use the sliders to transform these scores so that they lie in the interval from 50 to 100. In this homework activity, you should repeat the preceding process 5 times, until you are confident that you can transform any starting scores to any interval that you wish.